Today we are covering causal masking. Why GPT cannot see the future during generation. The goal is not to memorize a slogan. The goal is to build an interview-ready explanation that moves from intuition, to mechanics, to trade-offs, and then to a concrete example. Intuition. Causal masking blocks attention from looking at future positions. During training and inference, token prediction must only use tokens that would already be known. If you remember only one thing, remember the shape of the problem, raw information is transformed into a representation that makes the next decision easier. Core mechanics. A triangular mask hides future tokens and decoder self-attention. Each position can attend to itself in previous positions only. This matches next token prediction training. It prevents information leakage from the answer token. The same idea supports autoregressive generation. The compact mental model is masked scores equals scores plus causal underscore mask before softmax. Do not rush past the symbols. In an interview, define each part in plain language before you talk about implementation. That makes you sound like you understand the system, not like you only memorize notation. Common traps. Without the mask, training can cheat by seeing future tokens. Masks are applied before softmax, often with negative infinity padding. Masks and causal masks solve different problems. Causal attention limits parallel dependency at generation time. Concrete example. When predicting the word after the capital of France is, the model can use those earlier words, but not the future answer token Paris. The mask enforces that rule. Walk through the example slowly. Say what changes at each step, what stays fixed, and why the operation helps the model produce a better representation. Interview checklist. Draw the lower triangular matrix. Verbally explain no future peaking. Say mask happens before softmax. Connect to next token prediction. Separate training parallelism from generation order. A strong final answer for causal masking should have 4 beats. First, give the intuition. Second, name the components. Third, describe the formula or data flow. Fourth, mention the trade-off. If you can add one example, you will usually sound much more practical than someone who only gives a textbook definition. Now let us rehearse the answer in a more conversational way. Start broad. What problem are we solving, and why did this idea become useful in modern AI systems? Then narrow down, what data structure or tensor is being manipulated? Then explain the operation, what is multiplied, normalized, added, masked, or learned? Finally, connect it to behavior, faster training, better context, more stable gradients, lower memory cost, or clearer generalization. For interview practice, avoid 3 mistakes. Do not give only math without intuition. Do not give only intuition without naming the mechanism. And do not pretend there is no trade-off. Most AI interview questions are really trade-off questions wearing a concept label. The best answer shows you know when the method works, when it becomes expensive, and how engineers usually manage that cost. Quick recap: causal masking. Why GPT cannot see the future during generation. Use the mental model, define the pieces, give the example, and close with the practical trade-off. That is the answer structure to keep in your head. One more interview rehearsal. Explain it as if teaching a teammate. Define the input, describe the transformation, name the output, and close with why the design choice matters in real systems. This habit turns a memorized answer into a practical engineering answer. Second rehearsal. If the interviewer asks for more depth, connect the idea to tensors and runtime behavior. What is stored in memory? Which dimension grows with sequence length, hidden size, or number of heads? Which part is learned, and which part is a fixed rule? These details separate a surface-level answer from an engineering answer.